Howdy folks, welcome back. So I got you over here at the seed site and we have 4 days of missing data now. My last video I showed you these 2 days of missing data, and from other instruments I've been watching, these 2 days there's not much change in the activity. So today we're going to do a tutorial on black holes. So first off, let's take the definition of a black hole here, and we'll simplify it too. A black hole is a superdense point in space formed by a collapsing stellar core more than 5 times the mass of the sun. A black hole's gravity is so powerful that even light cannot escape from it. So let's simplify this. A black hole really isn't a hole, it's a superdense stellar core that's more than 5 times the mass of the sun. A black hole's gravity is so powerful that even light cannot escape from it. So a black hole does not reflect light. Light cannot escape from it, so it can't reflect light. Okay, now to another important definition, the definition of a dark nebula. A dark nebula is a cloud of interstellar gas and dust that absorbs light and is only visible when silhouetted against a cloud of stars or another type of nebula. So a dark nebula is gas and dust, which is matter, that absorbs light and is only visible when silhouetted. Now here we are at September 10th of 2017. This is 13 days before the Revelation 12 star alignment in the sky. And the Revelation 12 states that a dragon appeared before the woman, draped in the sun with the moon at her feet and a crown of 12 stars. Well, this appeared 13 days before the Revelation 12 star alignment, and what we have here appears to be a stellar core that is sucking material off the sun. Here is a conduit of plasma that it's ripping off of the sun and into this object. I'm going to back it up a frame here, because in front of that appears to be another smaller stellar core with what look like wings coming off on the sides, which are actually debris tails of matter that is being ripped off of this core and sucked into the bigger one back behind it. And now I'm going to back it up even more, because it all started with this little object that was orbiting the sun. And if you look back behind it, you cannot see this other stellar core. It isn't silhouetted by the sun, so you can't see it. It's absorbing light. So as we go forward here, it causes a solar flare. Here it comes. You can make out the curvature on the backside of this object. Then the CME drapes over this, illuminates the debris tails, and then it silhouettes this bigger core back here, which, as we go further, this is like 45-degree angle still back behind the sun. This white circle represents the size of the sun, and with this object still back behind the sun, it's already bigger. I would say 5 times there, but as we go forward, I wish we had that frame, huh? As we go forward here, you can see as it starts to get perpendicular to the sun that it's actually much bigger. You can make out by this curvature here and estimate the rest of the size is right about there. This is about 10 times the size of the sun. And what did that definition say? A black hole is at least 5 times greater than the mass of the sun. Well, here we have an object that absorbs light. It's 10 times bigger than the sun. And what I think we're looking at here is a black hole. So here back at this image, you can see we have coronal mass ejection that is arching and draping over this object. This is the conduit of material that's being sucked into it, and you can even make out a damage ring or an impact zone from the mass of this slamming into the surface of this, creating a damage ring or an impact zone. You can also make out Nibiru, or this stellar core with the wings on it, sticking out in front. Now, science has coined this term black hole, which is kind of deceptive because the actual thing is a sphere. It's more of a black sphere that absorbs light than a hole in the space-time continuum, or whatever Star Trek taught you. Okay, so I backed it up a couple frames because I want you to take note of the date. It's September 10th of 2017, and take note of the time. This is 16:09:35 UTC time, because we're going to go to a different instrument, and I want you to note these times. So here we are at a different satellite on September 10th of 2017. It's 1600, and you can make out by this instrument right here, by its reaction, that we're starting to see a CME emerge from the sun. So I'm going to start taking this frame by frame. Already, we can make out curvature here. It's 1612, and material draping around it, just like before. In this image, you can make out the first stellar core with what appears to be almost like a little face on it here, with the mouth wide open, boom, boom. The same image that we have at 1624 here, the two eyes, what looks like the little mouth open right here, 1624. Okay, same mouth and image right here at 1624. So you can see this is the same event, and I'm going to start taking you frame by frame through this one. Here we have what appears to be a black sphere, and you can tell by this that the other sphere is actually bigger and back behind it. Let's go one more. You can see by the curvature coming way down here and draping around and going up and off the page that our main object, our bigger one, is probably right about here. The big 10 times the size of the sun one is right there. Then we'll keep going. Another frame, another frame, another frame. Okay. Now I back this up, and I'm going to put it into motion, and I want you to see what happens when this huge black hole goes ripping past our sun. One more time. Now here we are at a video I did called Nibiru's Procession. If you go back to my channel, click on the video tabs up at the top, all my videos will drop down. Scroll down to Nibiru's Procession. We're going to go through this really quick because I want you to take note of this date right here. It's 11/25 of 2010. Here's our object coming in and causing solar flares and CMEs off of the sun. I went back into the archives to see if this was happening before, and lo and behold, I found it at 2010. Now here it is at 2011 on the 13th of November. And as you can see, it comes by, makes more activity on the sun, and it makes a deeper pass. Now this satellite is taking these images from the back side of the sun opposite us. So we could not see this thing coming. The sun was blinding us. Here we are at 2012's pass, and it's November 4th and 5th. Okay. Now here we are at 2013's pass. Now it's in the month of September 22nd. Sorry, October 22nd through the 27th. Now here we go at 2014, October 12th. And each pass, it's getting deeper and deeper into the page, closer to the sun, and it's moving higher and higher up like this. Now to 2015, and now it's showing up in the month of September 27th. Now to the pass in 2016, September 18th. Now to the pass we had in 2017. It comes in, goes way back behind the sun now, emerges, sets off another solar flare, and our black hole image that we started off with right here with Nibiru in front. And the black hole back behind it. Whoops, right there. And that was 2017. Now here we are at the pass at 2018, and now it's showing up in August in 2018. And this time it goes way back behind the sun. So each time it's getting further back behind the sun, and we're on the opposite side of it, it's getting closer and closer to Earth, because Earth is back behind this. So each time this gets deeper, it's getting closer to the Earth. And that was 2018. Now here, I've compiled a list of all the dates of the events I just showed you, right here. If you notice, there's a little pattern going on. As the years increase, the months decrease. First, it was showing up in late November back in 2010, and then earlier and earlier and earlier and earlier, all the way down to August 25th of 2018. With this rhythm, I was able to project 2019, it's going to show up again in mid to early August of 2019, and we are finishing up the month of June and heading into July here real quick. So I wanted to bring this to you as a heads up, as a warning. This thing's due back here in about a month or so. And I hope you enjoyed this video. I hope you learned a little bit about black holes, that they're not really holes, that they're actually black spheres that are either rotating around our sun, or we may be rotating around it. If it has more mass than our entire solar system, it's very probable that we might be rotating around it, getting closer and closer and sooner, and a tightening spiral as we approach it. I hope you enjoyed this. I love you all, and I'll see you next video.